All right, so we're going to do 2,607 divided by 7. The first step is to punch in the number that you will be dividing. Next, you take what you will be dividing by, in this case 7, and you're going to take from that, subtract 1, and then compute its nines complement. So 7 minus 1 is 6. The nines complement is essentially just the inverse of its position on this set of numbers, or 9 minus it, or whatever you would take to get to 9. So kind of the flip side of 6 is 3. So just keep that 3 in your head. That's going to be kind of our like driving number. For each digit along our sequence of digits, we're going to repeatedly be adding that driving number following these two rules. The first is when we begin doing a number, we will add the driving number as long as the number of additions we've done on this step is less than the number 1 to the digit shown 1 to the left of the number we're working on. So in the example, that'll become more clear. And after we've done that, for as long as the digit we're working on is at least as large as what we're dividing by, we'll continue to add our driving number more. So starting with this 2, we don't have a digit to our left, so we can kind of pretend it's 0. So for that first phase, we don't need to do anything. And for our second phase, we don't need to do anything either, because 2 is less than 7. So we can move on to our next digit. So we're going to begin by repeatedly doing additions until we've done as many are shown on the left. The reason I'm not saying 2 additions is because of the potential for a carry. So I did 1, 2 additions, and you notice it rolled over to 3. So I'll do 1 more. So I've done 3 in total. So that finishes that first phase. For the second phase, we keep adding for as long as this is at least what we're dividing by. Now 5 is already less than 7, so we'll move on. Then we'll begin with 1, 2, 3, 4, 5 additions. I miscounted. I counted 1 as twice. No, that's because it rolled over to 6. Sorry. We rolled over to 6, so I had to do 6 total additions. And now what we have is more than 7, so we're going to do an additional addition for as long as what we have is more than 7, or 7 or more, sorry. So we did 1 more, and now 1 is less than 7, so we move on. We begin by adding 3 repeatedly. We rolled over to a 2, so we'll do it twice. Now 3 is less than 7, so we'll move on. So for that first phase, we didn't have any rollover, so after just doing the 3 additions, we're done that first phase. For the second phase, 9 is more than, or at least 7, so we will do 1 more addition. And now we have a 2, which is less than 7, so we'll move on, starting with 1, 2 additions. 6 is less than 7, so we'll move on, doing 1, 2, 3, 4, 5, 6, 7, 8 additions. Now 4 is less than 7, so we'll move on. We'll do 1, 2, 3, 4, 5 additions. 5 is less than 7, so we'll move on. 2, 3, 4, 5, 6. We've done our 6 additions, and now we're left with an 8, which is more than 7 or more, sorry. So we'll do another addition. And now it's 1, which is less than 7, so we'll move on, but we're out of digits. So this many decimal positions, this is 2,607 divided by 7. You can kind of do like analysis on the order of magnitude to say that the decimal place would be here. So our final result is 372.428571.